Hello everyone, welcome to the third session of the chapter Solvents. Technically, this session will be numbered as session number 12. In this session, we are going to study about some reactions in liquid ammonia and water. In previous sessions, we have seen classification of solvents and we have covered what are the similarities of liquid ammonia and water. Now, we are studying how the reactions occur, how few reactions occur in liquid ammonia as solvent and water as solvent. For your syllabus, we have these particular reactions: acid-base neutralization, redox reaction, complex formation reaction, and ionization of acetic acid. Okay. Acid-base reaction means an acid reacts with a base to form salt and water. In this process, you can realize that an acid and a base, when they form salt, they get neutralized. Hence, be it acid-base reaction or neutralization reaction, they both mean the same. So, I am going to discuss under only one heading, that is acid-base reaction. Then we shall see what is a redox reaction, how complex formation reaction occurs, and ionization of acetic acid. Let us look at this particular example. We all know HCl dissociates to give H plus and Cl minus. We have NaOH dissociates to give Na plus and OH minus. This one, when you complete the reaction, you are going to get NaCl and H2O. When you add up the complete reaction, you are going to get the main reaction that occurs when you carry out a neutralization reaction is H3O plus OH minus gives rise to 2 molecules of H2O. This is in presence of water. How neutralization occurs in presence of water? If you take neutralization reactions in base ammonia, it so happens ammonium chloride reacts with sodamide, which is a base. An acid and a base react to give salt and the solvent ammonia. So we are going to see formation of this particular reaction. So the overall reaction will be H plus NH2 minus gives rise to 2NH3. Okay, so this is a similarity of the types of reactions that occur both in liquid ammonia and water. Next, we have a redox reaction. Check this particular reaction. Fe2O3 plus aluminium gives rise to Al2O3 and Fe in plus 1 state. It's in liquid. It's in the liquid form you get it. Okay. Fe2O3 plus aluminium. Aluminium gets oxidized and iron gets reduced. So it's a redox reaction which occurs in presence of water. You do not see water involved anywhere here. It just facilitates the reaction as a solvent. Okay, in redox reaction, water facilitates the reaction as a solvent. But here, when you consider this, see, ammonia combines with oxygen to form nitric oxide and water. Okay, so oxygen is converted into nitric oxide and water. So you have a redox system. Here another example, ammonia combines with copper oxide to give us nitrogen, water and copper. So removal of oxygen is reduction. Addition of oxygen is oxidation. So this is once again a redox system. Here when you involve ammonia, ammonia itself undergoes a redox reaction. So it is a part of the redox reaction. Whereas when you consider water, it does not form a part of the redox system. It just acts as a solvent. Kindly do not bother about these vendors because it is lockdown. People are coming selling things home. Okay. I do not have an isolated room to make this soundproof. So kindly bear with me. Next, let us move on to complex formation reaction. So we know that complex formation reactions can be depicted in two ways. You can go on adding one ligand after another. Okay, these are the ligand molecules. These are the metal atoms. You can go on adding ligand one after the other until you get the final complex. Okay, see, one ligand molecule is added, so you have only one ammonia added. Next, this is the reactant. You add another ammonia, so you get NH3 twice. You add another ammonia, you get NH3 thrice. And finally, you're going to get your product. So, tetra ammonium copper 2 complex. Okay, this is the final product. You can do this stepwise or you can do it at once. Okay, so Cu2 plus 4 ammonia ligands, you're going to get this particular complex. So these are called as stepwise formation constant and this is called as overall formation constants, and the relationship between overall formation constant and stepwise formation constant is Kf is equal to K1, K2, K3 into K4. Okay, so in this reaction you can see that what ammonia can act as a ligand. When you add it as a solvent, sometimes ammonia acts as a ligand and it forms complexes. In very rare cases, you can even see water acts as a ligand, or else it only forms as an water of hydration. Okay, it may not act as a ligand. You get very rare cases of aqua complexes. But both ammonia and water form complexes. So see here, we have various complexes. Here, see, hydroxides are there, fluorides are there. Most of the complexes you do not have aqua as ligands. Okay, and then you have the step formation constants for various reactions. Moving on to the last reaction, ionization of acetic acid. For a strong acid and a strong base in water, the neutralization reaction is between hydrogen and hydroxide ion. We have discussed this in the first reaction. For a weak acid and a weak base, neutralization is more appropriately considered to involve direct proton transfer from the acid to base. For example, for the neutralization of acetic acid by ammonia, it can be written as this is acetic acid, we all know it is a weak acid, plus ammonia. So it forms an ammonium ion and an acetate ion. This equation does not involve the solvent. It is therefore also represents the process of neutralization in an inert solvent, such as benzene, or in the complete absence of solvent. If one of the reactants is present in large excess, the reaction is more appropriately described as dissociation of acetic acid in liquid ammonia or of ammonia in glacial acetic acid. So this is ionization of acetic acid. This does not occur in presence of water because it is a weak acid, but weak acids can dissociate and form a carboxylate anion in presence of ammonia. Okay, so we have discussed in this particular session acid-base or neutralization reactions, redox reactions, complex formation reactions, and ionization of acetic acid. Thank you.